Good afternoon, everyone. My name is Sibel Schapner, and I am the Federal Manager for the Advanced Sensors and Instrumentation Program. I will provide a brief overview of my program and then go over the topics under this solicitation that fall under this program. Okay, the mission of the ASI program is to develop advanced sensors and instrumentation to address technology gaps for monitoring and controlling reactors and supporting fuel cycle development. Our vision is to have our research adopted by the nuclear industry, and in order to do this, it needs to be qualified and validated. Our program, through our cross-cutting research, supports the Department of Energy Office of Nuclear Energy mission to advance U.S. nuclear power in order to meet the nation's energy needs by supporting the existing fleet, developing an advanced reactor pipeline, and supporting the fuel cycle and supply chain infrastructure. The goals for this program are to provide any R&D programs with INC capabilities to support the reactor or fuel cycle development. For example, empower instrumentation for fuels and materials testings that are needed to qualify them for commercial deployment. Second goal is to provide new innovative measuring and controls capabilities, such as sensors for harsh environments, advanced control capabilities, and fault-tolerant operations. And third, we want to help address R&D needs for successful deployment of these technologies. One example is digital technology qualification, but also advanced operational concepts and focused demonstration of the advanced technologies to provide science-level evidence for regulatory acceptance. Here are a picture of some of the documents that are available on our NE website that have more information on the research being conducted under the ASI program. Based on our stakeholders' needs, we have organized our research in 4 areas. First area, sensor and instrumentation. We're looking for reliable and cost-effective sensors that provide real-time, accurate, and high-resolution measurements. Second area, advanced control systems. We're looking for near real-time control of plant or experimentation processes. Third area, communication. We're looking for resilient communication technologies to enable real-time transmission of sufficient data for online monitoring and advanced data analytics. We are interested in wireless communication. And the fourth area is big data analytics, machine learning, and artificial intelligence. Here we're looking for technologies that enable semi-autonomous operation and maintenance by design. Since we are a cross-cutting program, our goal is to fund research that is applicable to multiple reactors or fuel cycle applications. For this year's solicitation, we're focusing on the communication area, specifically on wireless communication under NEET-2, and we also have one topic under NSUF-1.1. Please note that NEET-2 is open to universities and laboratories as leads only, but industry can participate as a collaborator. For industry interested in leading projects under these areas, I encourage that they submit their proposals under the industry FOA, and you can get more information on the GAIN website for that. They have an R&D portion in that solicitation where this research could fit. And NSUF 1.1 is open to everybody, industry, universities, and laboratories. So for NEET-2, our topic is wireless technology for nuclear INC systems. As you are aware, currently electrical cables are critical infrastructure necessary to operate a nuclear power plant effectively and safely. When considering advanced control modes for advanced reactor concepts, including microreactors, cable performance degradation in radioactive environments becomes an important limiting factor. In addition, wireless technology is increasingly deployed for the improvement and cost optimization in other industries. We are looking for proposals that adapt these proven technologies to improve the performance and cost effectiveness of nuclear systems. So there are three tiers to the deployment of wireless technology in a nuclear system. The first one is generation and transmission of data from a system component to a receiving element within the nuclear containment structure. Second, transmission of signals from inside to the outside of the containment. And third, transmissions of signals from outside containment to a control room or data cloud. Proposals under these NEET-2 requests shall address only Tier 1, data generation and transmission within the containment structure. One example of a wireless technology widely used in industrial applications that have produced large operational cost savings and still are not widely considered for nuclear application is radio frequency identification, or RFID. We're looking for technologies that will provide accurate data transmission under harsh nuclear environments. Please note that the other two tiers I mentioned may fit better under the cybersecurity program and won't be considered under this topic. Now switching areas in the solicitation, under the Nuclear Science User Facility 1 Workscopes, all applications, like I mentioned before, are open to labs, industry, and universities. And what we're looking here is projects coupling R&D with NSUF access. The topic listed under my area is NSUF 1.1. It's the same topic as last year, and we're looking for proposals in two areas: advanced materials for sensors and advanced sensors. Both of these areas offer an opportunity to test any materials proposed for advanced sensor for survivability and performance in nuclear environments, and any sensors and associated instrumentation for nuclear energy applications. Please provide a description of the materials of sensors, what irradiation and post-irradiation examination are needed, and how these materials or sensors will benefit new sensors and applications. And new this year, we're asking for a technology gap analysis to assess the impact of the proposed technology in comparison with existing solutions. So please review the recent competitive awards and programmatic work being performed in this area to ensure that there's no duplication of effort. And all this material is available on our NE website, and the link was provided in the Workscope. Again, please note that this is an opportunity to test your developed materials or sensors in an irradiated environment and document your results. It does not support new sensor or material development. And conclusion, some expectation for this FOA is, as you plan for your proposals, we're looking for advanced INC technologies that will support reactor and fuel cycle development and deployment with improved economics. Demonstration of proposed technologies in a setting that represents the nuclear power industry. And innovative and revolutionary cross-cutting technology that can be applied to multiple reactor designs and fuel cycle concepts. Please note that there are other INC-related topics under other sections of this FOA that complement the research we are doing under ASI and provides additional research opportunities for the nuclear INC community. I coordinate closely with my colleagues in those areas to make sure there is no duplication. And Craig Primer and Brandon Hydrons from the Idaho National Laboratory are the technical leads for these two areas. And here's our contact information, so please reach out to us with any questions. They are also available during this webinar to help answer any technical questions. And I haven't tested, but I think they should be online also. So are there any questions? Thank you.
Subel, let me unmute Brendan and Craig. Brendan, you'll have to unmute yourself and then let me know. There we go. Are you there?
I'm online.
Okay, we can hear you. And Craig has been on a previous session, so I'm sure his mic works. Craig?
Thank you. Yes.
Okay, we are ready for questions then. In NSUF 1.1, is this scope ITAR restricted?
Can you repeat the question? I couldn't understand the last part.
Is this research ITAR restricted from an export control standpoint?
This is Brendan. I guess certainly it could be, but all NSUF work is intended for open publication. So if there was, it would be unlikely we would accept something like that.
Are you interested in dose information or a particular type of radiation?
Brandon, I'll let you answer that.
It would be helpful to have some specifics, but you may not want to get into that right now. If you can relate it to the goals in the work scope, then we'd be interested to see the proposal.
Are you interested in correlation with mechanical properties, creep, or fracture toughness?
Absolutely.
I believe this is probably for NEET-2. Is the use of radiation harvesting for sensor power sources a benefit?
Yeah.
So the business case side of it is definitely part of the overall consideration.
We will keep these individuals on the line for the next 2 to 3 minutes. Please do submit your questions now if you have them. We have a few more questions. Can the sensors be located outside the containment? This is for NSUF 1.1.
Okay.
Is for 1.1 or is it for For 1.1, I don't think we have restriction for where the sensors are located. It has to support the nuclear industry or nuclear application, I guess.
Sorry, Subel, this is for 1.1, so you were correct.
Did I answer the question? Sorry.
Seems like it to me.
Okay.
We'll see if a clarification question comes up, but I think you answered it.
Okay.
Is environmental exposure of interest either simultaneous with the radiation or separate?
Are we talking about 1.1 or 1.2? Maybe
It
we should
isn't
have broken down the
specified.
question.
For those asking questions, please do specify which workscope area you're referring to. My assumption would be this is probably for
1.2.
1.2.
You were looking for a nuclear environment, so it has to be for harsh environment.
For testing of advanced materials for sensors, is using of electron beam acceptable to appropriate gamma dose? Oh, to approximate gamma dose, excuse me.
Brandon, can you answer that?
Certainly, I guess that's something that you could use for a pre-characterization. NSUF doesn't offer any electron beams, but we do offer a variety of high-level gamma irradiation facilities. So obviously, we'd like these testing to be as close to the prototypic environment as possible. So as Subel said, industry would be more likely to want to adopt these technologies.
For the NSUF scope, should we look at a particular structural material, steel or concrete, or can we have a broad approach?
Yeah. So obviously, you would need to find materials that are important to DOE Office of Nuclear Energy. Steels and concrete certainly cover that. So write the proposal for what you'd like to see.
What level of dose for irradiation are you interested in NSUF?
These are generally for in-core applications, so obviously it's very high dose, but it would have to be whatever, at least whatever is appropriate for the lifetime of the detector, and obviously that can be variable. We can work on that. You can actually contact me for the technical side of trying to plan the experiments, or I can assign you another tech lead for that. We can figure that out, but it would need to be, you know, around the actual dose it should experience in or near the reactor.
Are you looking for a particular type of radiation in the NSUF scope?
Once again, it should be similar to the prototypic environment, so neutron and or gamma.
Okay, those are the questions. Oh, hang on, we do have one last one that just came in. For the NSUF scope, can we use wireless RF transmission equipment?
Certainly wireless has been an area of investigation for a while. Reactor vessels tend to be big Faraday cages, so you just have to explain how that would work, but wireless is certainly of interest.
Okay, it looks like those are the questions that we have. Thank you, Brendan. Thank you, Craig, and thank you, Subel, for the presentation. We will pick back up at, it will be 4 o'clock Eastern time for the microreactor scope. So please join us if you have interest in that scope. Thank you.
Thank you.